Okay, let's start it. Hello guys, welcome to the second lesson of ODBA from Introduction to Practice. I'm your old friend Peng Wang, the Global Technical Evangelist for OceanBase. Today we are delving into the installation and deployment of the OceanBase Community Edition. This is the crucial step in your journey to mastering OceanBase, as setting up a solid foundation will ensure smooth operations down the road. In this session, I will guide you through the process step by step, from preparing the environment to successfully deploy your OceanBase instance. Whether you are new to database systems or looking to expand your skills, by the end of the session, you will have the confidence to install and deploy OceanBase in your environment. Okay, let's get started. This issue will be explained in 5 parts. The first part is deployment preparation, which mainly talks about server initialization. The second part is the introduction of deployment-related ecological components, which mainly introduce some functions of 3 deployment tools. The third part is the deployment of personal experimental environment. It should be emphasized that a personal experimental environment is prohibited from being used directly in a production environment. The first part is the deployment of the production environment. This part will explain some precautions for different tools to deploy production environment. The fifth part is the introduction of some technical usage after the cluster deployment is completed. Before deployment preparation, let's take a look at how to obtain our installation package. There are 3 ways to do it. The first is to download it directly from the official website. The second is to download it from our GitHub. The third is to configure some official YARN sources and install them remotely through the subsource. Yes, you can see it. The first one is our OBD installation package, which is the OceanBase installation and deployment tool. It's an independent entity. If you are in a public network environment, you can directly install our service remotely by downloading this package. If you are in an offline environment, you need to download the database installation package by your own. The second one is our database package. Here we need to introduce that our database have 3 packages. You can see. The first one is the database package itself. The third one is its libraries dependency package. And the third one is database to integration package. If you download it separately during the download process, we recommend you that user download the package of the same version. In this way, when different deployment tools are installed, it will verify the specific version of the package to perform the database consistency check. The third one is our 𝘤𝘂𝘶, which is also an independent package. You can download different versions from the official website according to your needs. The latter 2 packages are special. The one-click installation package is an all-in-one package after decompression, because the package contains a series of installation packages in addition to the database, such as OBD, 𝘤𝘂𝘶, OCP Express, and others. OCP Cloud Platform after decompression is also an OCP all-in-one directory, which contains OBD, OB proxy, and OCP in addition to the database. Here we have two directions. They are, if you use OBD to deploy, we recommend you directly download an OceanBase all-in-one offline package. In this way, you don't have to consider the public network environment. The second one is that if you want to deploy the OCP cloud platform, directly download the cloud platform installation package, because it's basically enough for a production environment or a test environment. Okay. In the deployment preparation, it's introduced that there are 8 steps. It's the organization of the server. We will introduce several important in detail. The first one is to create user and groups. Currently, OceanBase already supports the use of any operating system user for deploy. But before deployment, we need to create the deployment user on each node first. And when creating the deployment user, we need to create the UID and GID of the users on each node consistent. Because when NFS is used as a backup medium for data backup later, access to the backup directory may fail due to inconsistent UID. It needs attention. The second is to configure the user's SSH mutual trust. Currently, our OCP and OBD deployment tools have no strong dependency on this. So this can be configured or not, according to users' needs. The third is pseudo password free. If OCP is used for deployment, pseudo password free is required. But if OBD is used for deployment, it's not required. The first is disk and file system planning. There are several key points to introduce here. If you are in a personal learning environment, there is no great requirement for disk capacity and disk type. We currently only support ext4 and XFS for file systems. If you are in a production environment, we have several requirements. The first is that it must be an SSD disk, and the data disk, log disk, and transaction disk must be separated and deployed in different disks. This must be configured in the production environment. If it's deployed in a personal learning environment, it will remind you in the form of an alarm. The fifth and sixth steps are the same configurations about system parameters. They must be configured in the production environment. If it's a personal learning environment, it will remind you in the form of an alarm when the personal learning environment is deployed. The seventh is the firewall and SE Linux. This is adjusted on demand. If your environment has some security requirements, you'll need to turn on the firewall. This requires opening some OceanBase related port IP at the same time. For SE Linux, we recommend to turn it off, because SE Linux will cause some permission issues for some users. This parameter needs to be explained. When it's configured, it needs to restart the server to take effect. Of course, it also has a temp way to take effect, but it's a production environment. No, we recommend you to restart the server after the initialization is completed. The S is the clock source. This must be configured in a cluster environment, whether it's a personal learning environment or production environment. Currently, in version 4X, we have supported the time difference between nodes within 2 seconds to maintain normal service. If it over 2 seconds, some problems such as error switching the master node will happen. it's recommended to configure it for the stability of the cluster. For some specific configuration method, please refer to the configuration process on the official website. Okay. The second chapter is an introduction to deploying related ecological components. We have three deployment tools. They are OBD, OCP, and OB operator. There are some key notes here. Let me reintroduce them. Regarding offline and online deployment, OBD can also be deployed offline. It also has a remote warehouse, so it supports both. OCP can only perform an offline deployment by uploading the database installation package and does not support an online deployment. OB operator can be deployed online and offline like OBD. Here is whether the deployment tools support high availability. OBD does not support it because it's an CLI tool and it doesn't support high availability. OCP supports it because it can deploy a multi-node environment to achieve high availability. The deployment of OB operator depends on the Kubernetes. If the Kubernetes have high availability, then OB operator also has it. The next question is whether it supports single machine multi-node deployment. First, OBD supports it through its CLI-based configuration file deployment method, allowing single machine multi-node deployment by simply modifying the configuration file. OCP does not support it because OCP itself is deployed and verified according to the requirements of the production environment. So it will check whether the node has been deployed and whether there is an OB server process before deployment. So it doesn't support a single machine multi-node. OB operator can also support multi-node deployment through configuration files like OBD. Regarding the ecological docking, OBD and OB operator have already opened the source code, while OCP is not open source code, but some APIs are open. It has an OCP Express tool. That is a lightweight tool, and it's currently open source. However, the key difference between it and OCP lies in their varying operation and maintenance capabilities. There is a problem of resource usage of deployment tools here. OBD and OB operator here have lower resources requirement, about 1 CPU core and 1 G memory size. This resource can be deployed and used. But OCP will occupy more resources because it has a metadatabase named MetaDB. Currently, only OceanBase is supported as MetaDB. Therefore, this OceanBase is deployed according to the production requirements, and its resource usage will be high at this time. Okay, let's move on. The third chapter is deploy the personal experimental environment. Let me introduce the deployment of personal experimental environments. We have 3 experimental environments in total. The first is the demo environment. The second is the cluster environment, and the third one is the container environment. First, let's introduce the demo environment. It's actually a standalone system. The system does not occupy a lot of resources, and can be used for some basic test, functional verification, and performance test. One of its main features is to be deployed fast. The OceanBase only have 6G memory resources when deploying the demo environment. Some other components are also deployed by default, such as OB proxy, Prometheus, and Grafana. Refer to the quick deployment command. You can refer to the quick deployment command. If you need to deploy specific components. It's a link that contains many commands. For example, this OBD demo command. This command is to deploy only one OBD OceanBase. No other services will be deployed. It only takes 1 minute or 2 to deploy, so it's very fast. The default cluster environment is to use an OCP Express for monitoring. This will loosen the resource requirements. If it provides these resources according to the configurations of a production environment, it can actually be used as a small cluster production environment. However, there is the problem that OCP Express has weak operation and maintenance capabilities. If your business volume is not large, there are few cluster nodes, and you don't need GUI operation and maintenance, you can also use it as a production environment. Let's look at the last one, container environment. This is a small standalone environment deployed in Docker, which is not suitable for production and permission testing. If you want to deploy a container environment, it's recommended to use the OB operator. It should be noted here, we do not promise the stability and the performance of the deployment environment under Docker for the time being. But if you use the Kubernetes and the OB operator to deploy, you can apply it to the production environment. Okay? The next chapter is deploy production environment. Let's take a look at the deployment production environment. Let's first introduce its high reliability deployment solution. There are seven deployment solutions in the official document, but only 4 are compatible to the OceanBase Community version. The first one is 3 data center and 3 data replicas in the same city, as shown in the figure 1. The second is the 2 locations and 3 centers master backup deployment, as shown in figure 2. The third is 3 locations, 5 centers, and 5 replicas, as shown in figure 3. The fourth is the 2 data centers and master backup deployment in the same city, as shown in figure 4. Okay. Before deploying the production environment, we need to plan our deployment requirements. At present, our server software has been adapted to mainstream server, and mainstream software and hardware has been adapted. For specific information, you can check the OceanBase official website, which contains the introduction to supported software and hardware. In addition to some regular initialization requirements, our server also has some command dependency. This dependency is also mainly reflected in other service ecosystem components other than OceanBase. For example, OCP will have Python version and Java version requirements. For specific information, you can check the OceanBase official website. The next one is resource planning. There is a recommended requirement and minimal requirement in the production environment. If your production environment wants to run stability for a long time, it's recommended to configure resources according to the recommended requirements. For example, for CPU, we recommend 32 cores and a memory of no less than 32 GB. For this configuration, you need to pay special attention, and many users will have problems here. It's extremely recommended that users do not use HDD. When your business runs for a long time, the performance of HDD will be very poor, which will seriously drag down the entire cluster. So we recommend that users use SSD in the production environment from the beginning. The second is the file system. Currently, we only support XFS and ext4 file systems. We do not support other file systems for the time being. The last one is the capacity planning on the disk. We have a simple calculation formula for this planning, which is to allocate the disk capacity according to 6 times the memory capacity you allocate to the database. There are 2 points to note. 1. The memory is the database memory, not the systems. 2. The disk capacity includes the space for storing data, nodes, data logs, and transactions of the database. Okay, let's take a look at the third one, user planning. Currently, some users are supported to deploy. The only requirement is that the user needs studio permissions. The first one is the directory planning. We currently have 3 directions: the installation direction, the data direction, and the transaction log direction. There are no special requirement for the installation direction. The data disk and the transaction disk must be SSD, and they are deployed in the different disks. For capacity planning, I can briefly introduce that the minimal recommended data directory is 20 GB, which is the minimal standard. Okay, the next chapter is about deploying the production environment. We have several deployment solutions, which are introduced here. There are still some differences between them. The first is to deploy through OCP. We recommend the users to use OCP for deployment. Why do we recommend OCP? The first reason is that OCP actually has 2 GUI management tools. One is OCP, and the other one is OCP Express. OCP Express is a lightweight operation and maintenance tool that only supports some parameter management, tenant management, and some simple monitoring functions. Moreover, its meta tenant is placed together with the business cluster, and is only suitable for some small cluster environment. If you have high requirements for GUI operation and maintenance, such as data backup, some expansions, or some upgrades, this can be operated directly in the GUI of OCP, but is not supported on OCP Express. The second is some common architecture of OCP. Currently, it's divided into standalone and high reliability. Standalone means deploy OCP and its metadata on only one server. High reliability is 3-node OCP and 3-node metadata cluster. How should we choose between these 2 OCP architecture? Yeah, maybe you have this question. If you have high requirement for your production environment and manage a large cluster, we recommend to use some high reliability architecture. If your cluster size is within 4 nodes, the standalone organizations basically meets the needs. Next is MetaDB. Currently, we only support using OceanBase for this MetaDB. In this MetaDB, we will store 2 OCP meta tenants. one for MetaDB storage, and the other for monitoring data storage. Here we need to pay attention to that not recommended for user to share meta tenants, and we also don't recommend the user to share meta tenants and the business cluster, because the amount of OCP monitoring is relatively large. If it shares a tenant, its resource will encounter the bottlenecks. The third one is OCP. What are the server resource requirements for OCP? There is a simple template. Our cluster is 17 CPU cores and 60 GB memory. For specific resource allocation, please refer to the table next to it. During use, please pay attention to MetaDB disk resource usage. At the same time, we recommend GUI deployment. You can refer to their steps to use OCP to deploy a cluster. At the same time, there are some preparations that we will introduce. Okay, this page, we will introduce the steps to use OCP to deploy a cluster and precautions in these steps. The first step is to upload the software installation package. When uploading the software installation package, we need to pay attention to the following two notes. 1. Upload the required version installation package, which requires version matching. 2. OCP uploads the built-in database-related installation package by default. The second step is to add a host. There are several points to note. The host node needs to turn off the firewall and SE Linux. 2. The host node needs to use a static IP address. 3rd, the host node needs to create a credential operating system user in advance and configure sudo permissions. 4. The deployment user of the host node and the OCP node needs to have the clock command operation permission. If you don't have this permission, you can use the root user to do the command. The third step is to create a new cluster. Use OCP to deploy a business cluster. You need to pay attention to whether you need to customize the OceanBase system parameters, such as the number of system logs to be returned and the disk preoccupied size. The first is to create a new business tenant. The reason why we put this step here is that we found that some users directly use the sys tenant as the business tenant after the deployment is completed. It should be emphasized here that we prohibit to use the sys tenant as the business tenant. The last step is to create OP proxy cluster. If it's a production environment, it's necessary to create an OP proxy cluster because it has some permission optimization for our query routing. There are 2 points to note here. 1. It's recommended to back up the root password. The password will be used if you need to take over OP proxy later. 2. It's recommended to deploy a 2-node OP proxy cluster at least. If the business volume is large, it's recommended to deploy the OP proxy cluster on a separated server. Okay, let's move on. Let's take a look at the deploying a production environment through OBD. Here is the common architecture with the total of 4 nodes. One of the nodes will be used as the central control node to deploy OBD installation and deployment tool. Of course, this node will also be used to deploy OCP expression. The remaining 3 nodes consist of 3-node cluster for OB server, 𝘕𝘂𝘁𝗃 and 𝘤𝘂𝘵 agent. Here are some points to note. 1. The central control machine is recommended to have no less than 4 CPU core and 8 GB memory. The second, components can be selected by user and deployed, and deployment can be taken over. There are 3 ways to deploy OBD here, and we provide 3 solutions in total. If you are in a public network environment, you can directly deploy it by pulling its RPM package. If you are in an offline environment, you can use our all-in-one package. The third is to use the source code. That way it's more suitable for developers. Here are some points to note. Choose different deployment tools based on different requirements for operation, maintenance, and Java versions. Please note, we have several high-risk OBD commands. It should be emphasized here that they are destroy, redeploy, and reinstall commands. On this page, we have listed some common OBD commands. You can pay attention to them after this lesson. Let's look at what's involved in deploying the production environment through OB operator. The fourth requirement is that the resource provided by Kubernetes are 16 CPU cores and 36 GB of memory, and the storage space is not less than 200 GB. Why the memory requirement is 36 GB? Because OB operator allows for memory to OceanBase at a ratio of 90%. It's converted to 32 GB. It's consistent with the production requirements deployment on the physical machines. Before deploying the OB operator, we need to install 2 plugins. You can check out these 2 links. The entire deployment process will be introduced here. You can check out the official document. There are 2 points to be noted. 1. OB operator version 2.1.2 start to support the production environment deployment. 2. OB operator version before 2.2.0 or OceanBase version before 4.3.0 will rely on the Calico network plugin. The next chapter is an introduction to basic cluster usage. Next, let's take a look at the basic usage of the cluster. There are 2 cycles involved. The first cycle is to check the usage of cluster's resources. The following cycle is used to find the information in the screenshot below. It queries the OB server nodes and all zones. From the feature, you can see that the cluster CPUs, memories, and disk space, and other informations, including the allocated and remaining capacity. Here we need to pay attention to that. If you have just deployed the OceanBase, you may find the value, this data disk divided by log disk will occupy large amounts of the cluster deployment. The reason is that the data disk size controlled by the parameter data file size and the data file disk persistence is pre-allocated, and this parameter does not support reduction. The log disk size controlled by the parameter log disk size and the log disk persistence is also pre-allocated, but these parameters can be adjusted, allowing for both increases and decreases as needed. Let's look at the second circle. which is about how to view the details of the cluster resource locations. You can see the screenshot below. What we are querying, there is only the sys tenant in the current cluster, as well as its CPU, memory, disk size, and other informations. Next, let's look at several ways to create tenants. The first is to create tenants through OCP. The picture shows the interface to creating a tenant. It should be noted here that if you have requirements for IP access, you can customize the whitelist of IP addresses. If there are no restrictions, you can choose to allow all IP addresses to access. If I encountered problems during the creation process, I can view the login information from the right site, or you can download the login information directly. Next, let's take a look at how to create a tenant using OBD. Here are several OBD commands for creating and viewing tenants. Here we need to pay attention to that it's recommended that the latest version of OBD be used. Here, OB422 is the name corresponding to the OBD cluster list deploy name. Test2 is the name of tenant created in the test example. The resource unit name used by the tenant created using the OBD command is the tenant name unit, and the resource pool name is tenant name pool. The root user password is the tenant is empty by default. Finally, part is to use the command line to create a tenant. Creating a tenant consists of 3 steps. Creating resource unit specification. This step is optional. If you have suitable specification, you can skip this step and reuse directly. The second, create a resource pool. You can have one resource pool for each zone. Using the independent source unit specification, or all zones can use the same resource unit specification, all under one resource pool. The third one, creating a tenant. When creating a tenant, you can use link it to the resource pool established in step 2. We need to pay attention to that. By default, after a tenant is created, the root user password corresponding to the tenant is empty, and in the production environment, it's recommended to adjust the password by this command in time, and log into the corresponding user tenant. The 2 sides of C code on the left side are both used to create a business tenant. The difference is that the resource pool used in the create tenant is that below C code is to create zone resource that are distributed in different zone lists, while those above are distributed in one zone list. Next, let's see how to connect to tenants. After we create a business tenant, how do we connect to the business tenant? Here is an example to connecting a tenant. There are several parameters to introduce. The first one is the -u. It has 2 formats to specify the tenant to connect to. If no tenant is specified, the default connection is to the sys tenant. The functions of other parameters are similar to MySQL, so I won't introduce them here. There are a few things to note when connecting tenants. When connecting directly to the OB server, the cluster name cannot be included. About OB proxy connection, if there are multiple OceanBase clusters, the cluster name is required. If OB proxy is started through RS list, you can specify the cluster name or not. You can confirm the root service list parameter. If OB proxy is started with a configure URL, the cluster name must be specified. You can confirm the OB proxy configure server URL parameter. It's also important to note that when deploying OB proxy, there are two deployment methods. RS list the deployment method. When starting OB proxy, you can specify the root server information of the OceanBase cluster by specifying the -r parameter in the command. Configure URL deployment method indicates how to query the root server information of the OceanBase cluster by specifying OB proxy configure server URL parameters in the command when starting the OB proxy. What is RS list? The RS list is the IP list of the machines with the root service started in the OceanBase cluster. Next, let's look at the ways to view and modify parameters as well as precautions. Because clusters are deployed and managed using different tools, parameter management is also different. When we use OCP to manage cluster, we can find the cluster we want to operate on the GUI interface. This is the parameter management module under this cluster, which will display some parameter information. It also provides a search box to help us quickly locate the parameters we want to view. The second is to view through OBD. This is a command to view parameters using OBD. Please note that OBD command only can view the database parameters configured when using OBD deployment. The last one is to view through the 𝘂𝘁𝑐𝗍 command. Here are two 𝘂𝑁 samples. Two 𝘂𝑁 samples. Next is how to modify the parameters. First, here is an example to how to use the 𝘂𝑁 to modify parameters. Then modifying and viewing parameters on OBD and the OCP are similar, but it should be noted here. 1. If the environment is deployment in OCP, whether you adjust the parameters directly on OCP or the 𝘂𝑁 command line, both OCP and the command line will show the adjusted values. 2. If it's an OBD deployment environment, after modifying it through edit configure, the modified connect can be seen normally in the command line. On the contrary, if you adjusted the parameters through the 𝘂𝑁 command line first, then view it through edit configure. It's still the content before the modification. At this time, if you forget to add -WOP when you stop and start OBD, the original modification configuration will be lost. The third, you can use the fan command to confirm which parameters need to be reinstalled or restarted to take effect after modification. Next, let's look at how to view and modify variables. There are two ways here because OBD does not support viewing variables. This is similar to previous way to view and modify parameters. You can take a look at by yourself. It should be noted here that when you set global level variables not affected in the current session, effective in the new session. At this point, you may have questions. What's the difference between parameters and variables in OceanBase? Okay. The next part is the comparison of the parameters and variables. You can find your answer in this part. We compare different aspects such as query method, life cycle, and durability, and others. I won't introduce them here. You can take a look by yourself. Okay. Now let's review the key points of this lesson. The first one is we have OBD and OCP deployment tools. Do you remember the difference between them? If you forget, you can watch the lesson again later. The next key point is the production environment. OceanBase supports the deployment of 5 centers and 5 copies in 3 locations. The last one is free. OceanBase is an open source database. Go and try it in your environment now. If you have any questions, now is the perfect time to ask. Okay, let me check. Okay, no questions? Good. Before we wrap up, I'd like to remind you that our next lesson will be on the evening of November 5th, where we will be covering the OceanBase performance test. We look forward to seeing you then. You can also reach out anytime through our OceanBase Discord or GitHub community for further assistance. We are always here to help. We will be sharing how you can access the course materials and today's presentation slides in the comments section of this video. All the resources are free. Don't forget to subscribe to our OceanBase YouTube channel and join our community to stay up to date and get involved with us. See you guys. Bye-bye.